Hello everyone, welcome to the third lecture. In this lecture we are going to learn about what is current. Okay, so current is nothing but electric current is the rate of flow of electrons in a conductor. Okay, so the SI unit of current is your amperes. Okay, so it is denoted by a letter called A. Okay, so how does the current flows inside a conductor? Okay, so let us suppose there is a battery, or you can say an electromotive force. This is the positive terminal of the battery and this is the negative terminal of the battery. So the electromotive force aligns the electrons in a same direction and they start to flow. So electrons flow from the negative terminal of the battery and the positive towards the positive terminal of the battery. Okay, so electron starts to flow from the negative terminal to the positive terminal, and that results into the production of conventional current. Okay, so from this diagram we can see that the current starts to flow in this direction. So this is the direction of current. The green arrow indicates the direction of electrons and the orange arrow indicates the direction of your current. Okay, so it starts to flow in the opposite direction. That means that it flows from the positive terminal of the battery towards the negative terminal of the battery. So we can see that the current always flows in the opposite direction as of with respect to electron. Okay, so the flow of current also depends upon the type of the material that we are using. For example, in case of conductors, so what are conductors? Conductors are special substances in which the electrons are loosely held. Okay, they are loosely held. So a small application of EMF or electromotive force, or you can say potential difference, results into the flow of electrons. Whereas, for example, in case of like the example of conductors are like metals. Okay, then we have like saline water. Okay, these are some example of conductors. It is very difficult for the current to flow. The reason for that is because the charge is seldomly it is distributed. So the application of EMF, for example, like in case of like plastics, okay, or in case of wood. So these are some examples of insulators, and insulators restrict the flow of free electrons. Okay. Next one we have is the sign convention. For example, let's say, okay, so we have some sign convention. Let's say there is a current flowing in this. Let the value of the current is I1, and a second current which is flowing like this. Let's say this current is equal to I2. So I1 will be equal to of minus of I2. It means that what is negative sign? Negative sign just depicts the direction of the current. Okay, so it just shows us the direction of the current. Okay. So the formula that we use mathematically, current can be explained as I is equal to d upon dt of q. So this formula is important from numerical point of view. Okay, so this is a very important formula and you need to remember that. Or you can say charge is equal to integration of, so it is equal to the integration of current into I dt. Okay, so this is also a very important formula. Okay, so next one we have is the types of current. Okay, types of current. Okay, so basically we have two types of current. The first one is the DC. So what is DC? So DC, okay, so DC means direct current. Okay, so as the name suggests, the current which have same magnitude or constant magnitude as well as direction, as well as same direction. Okay, this current can be termed as DC current. Okay, for example, in case of DC, like if we plot its waveform, let's say the x-axis represents the value of time and the y-axis represents the value of current. Okay, I. So we can say that in case of direct current, the magnitude of the current remains constant irrespective of the with changes in the time. So you can say the magnitude, as you can see, the magnitude is constant. Okay. Second one we have is called the AC or the alternating current. Okay. So the alternating current. Okay. So what are the features? What are the properties of alternating current? Its magnitude as well as direction constantly changes with time. Okay. They changes with your time. Okay. And that is termed as an alternating current. Okay. For example, if we want to draw its waveform, so if you want to draw its waveform, it will be drawn like this. So current is constantly changing its direction. Okay. So on the y-axis we have your current, and on the x-axis we have your time. Okay, as you can see, the current is constantly changing. Okay. So that's all for today. In the next